When we think about ocean pollution, we think about plastic debris accumulating on the surface, a pollution we can easily measure and indicate. But the surface is only the beginning. As floating debris breaks down, they sink and fracture into microplastics. Then, deep underwater, microscopic marine life mistakes this plastic dust for food and ingests them. The pollution then travels up the food chain, from small fishes to top predators and eventually to humans. A big crisis, therefore, is occurring where we can neither see nor reach. But we found an opportunity to attenuate that. Marine fungi are among the least studied organisms on the planet. But recent research has revealed something unexpected. Certain species can degrade plastic. The question is, how can we use biodegradation as a way to minimize the impact of plastic contamination in the deep sea? We found the answer. Meet Amyko. Amyko is a small modular research instrument whose outer shell is made from CMCSP, a special type of bioplastic developed by researchers at the Riken Center that dissolves on its own in saline water without any leftover residues. It is also 3D printable, allowing researchers to adapt the fungi and the plastic properties according to the conditions of the target environment. Inside of Amyko, there are alginate beads containing cultured colonies of plastic-digesting fungi waiting to be released. Polyethylene, the most common plastic in the ocean, can be broken down by the Perenniodontium album, while polyurethane can be degraded by the Cladosporium halotolerans 6-UPA1. These fungi attach to plastic surfaces in the deep sea, releasing specialized enzymes that cleave long polymer chains into monomers and absorb them as food. The delivery is handled during ROV missions, remote-operated vehicles that already visit the area. Using its manipulator arm, it places the units directly onto the plastic sediment without disturbing the surroundings. Amyko is for researchers, and each deployment gives them a site to study how these organisms behave in real deep-sea conditions, how fast they work, and how far their impact reaches. Amyko's geometry is engineered with hollow parts for better flow, and joints that allow individual units to interlock and expand into a scalable mesh to cover any contaminated area. Within 8 hours of contact with seawater, the CMCSP shell will begin to dissolve and release the water-soluble alginate beads across the target area, releasing the fungi on the plastic. What remains is rigorous testing of the device and of the ecological response before any deployment. Amyko, the deep has been waiting long enough.